Here's how to master the refrigeration cycle. So this graph here is known as the pressure enthalpy chart, also known as pH chart. On the x-axis, we have enthalpy, also known as H. H equals total heat, so that's the sensible and the latent heat. On the y-axis, we have pressure. So this here is what they call the envelope, and it represents the phase change of the refrigerant. So as you increase pressure and temperature, you will turn from a liquid into a vapor. Everything in this region is a superheated vapor. Everything in this region is a saturated mixture, and everything in this region is a subcooled liquid. So this line represents the change in state. You can actually map out your refrigeration circuit within this graph. So let's start at the compressor. What the compressor does is it creates a pressure differential. We have a suction gas coming in through here, discharges out through there. So coming in through here, we have a lower pressure, lower temperature, saturated vapor. But coming out of the compressor, we have a high pressure, high temperature, superheated vapor. So this here is our discharge line. As I mentioned, it is a superheated vapor. It enters the condenser coil, which has air passing across it. As the air passes across that refrigerant, it rejects the heat into the atmosphere. So as the heat is being rejected, that superheated vapor is going to de-superheat, and then it will become a liquid at the outlet. So now as we became a full liquid, this here is the liquid line. It then enters the metering device. So what the metering device does is it restricts the flow of refrigerant, turning that liquid into 80% liquid, 20% vapor. It then enters the evaporator, and as that heat from the air inside the space is absorbed, as that heat is absorbed, that saturated vapor will reach past saturation and will become a superheated vapor.